Hello, let's continue our Sudoku adventure with X-Ban by sanabas. This is another leftover puzzle from our Escape the Grid theme week, so we're getting 2 Escape the Grids in a row. Thought that might be fun. It's kind of a mini Escape the Grid last last series of August. Anyway, so we do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We're also going to be placing digits outside the grid just where there are clues, where these lines intersect. And wherever we place, and sorry, a value, not necessarily a digit. We're going to place a value outside the grid. And it's going to be an X sum. So for 2-digit numbers, I recommend doing a corner mark for the first digit, maybe a 1, and then a center mark for the second digit, maybe a 2. So this would be read as 12. And that's going to count as an X sum. So the way X sums work is you look at the digit right next to the clue, in this case, this one, and that's going to be our X. So say it's a 4. Then that means X equals 4, and that means we're using 4 cells starting from that direction to sum to 12. So if this was a 3, we'd be using 3 cells. But if we're going to put 4, it's going to be 4 cells. And the 4 is included in the sum. So you're always including the X in the sum itself, which does affect the logic a bit. And so these 4 would then sum to 12. We already have 4, so these 3 would sum to 8. So we could do, say, 1, 5, 3. I think I did that right. I did not. 1, 5, 2. Yeah, so this should add to 12. Anyway, if it doesn't, pretend it adds to 12. Yeah, it does. 5 plus 5 plus 2. Okay. So this would fulfill a 12 X sum. Now, of course, I'm making a lot of assumptions here that this is a 1, this is a 12, and that this is a 4. But that would be one way to fulfill that clue, ignoring the rest of the puzzle. We also have Renbands. These purple lines are Renband lines. Many of them are completely outside the grid. Some of them are partially outside the grid. So values on a Renban are a set of consecutive values, but they could be in any order. So let's say this was 12. Then this would have to be either, these two would have to be, form a consecutive set with 12, right? So we could do, say, 13, and then maybe we could do like 14, 13. Now just pretend for a second that we're allowed to put, oh my gosh, what am I doing? Sorry. Imagine maybe I should have done that out here. So if this was 12, we could then do 14 and 13. Okay. Obviously inside the grid, we have to be 1 to 6. But here, 12, 13, 14 is a set of consecutive values. So this would be valid for this Renban. The order doesn't matter. What matters is that when you take them as a whole, they're a complete run of consecutive digits. So I couldn't do 12, 13, 15 because there's a gap, right? I'm skipping the 14. That's not a consecutive set of digits. Even though 12 and 13 are consecutive, 15 doesn't work within that range. All right, anyway, hopefully that makes sense. You've done Renbands before, probably in this series. Solution check will only check the digits inside the grid. So just, you only have to fill the inside digits to get the solution check to check your work. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how do we want to get started? Good question. There's not a whole lot going on here. We have 3 consecutive X sums. Some order. I wonder if that's a place to start. The other thing is, like, these 2 do peek into the grid. So these are consecutive. And so that means that these max at 8, right? So I could put 1 through 8 in here. I don't know how helpful that is. Now, some things to know about X sums. Let's actually talk about X sums a little bit. If an X sum of 1 is possible, but only if you put a 1 next to it. So this is possible. We could do a 1. An X sum of 2 is not possible at all. Because if we put a 1 here, then we're only using 1 cell and it would add to 1. If we put a 2 here, we're using 2 cells and it adds to at least 3. So 2 is not possible. So let's actually use this to record which ones are actually possible. 3 is possible, only as 2, 1. That's the only way to do it. So if I wanted this to be a 3, then this could not be the 2. So this would be 1 and this would be 2. And then that would make the 3 impossible because this would want to be a 2 as well. So actually, this cell, we can't put a 3 here or here. Yeah, we can't put a 3 outside here because if I put a 3 even here, right? Well, I could go to 4. Hold on. No, I could do 3, 4, 5. Hold on. So three is possible, just not with a 1. Sorry. So 3 is possible. You just can't do 1, 2, 3 on this line. That's not possible. All right. So that means I can't put a 2 here, I think. I don't think I can put a 1. Okay, I can't put a 1 here because 2 can't be an exsum. So it's not going to be 1. If I tried to put a 2 here, then I would need one of these to be 3 for sure. I could hide 1 as one of them, but the other would have to be 3, or I could do 3, 4. And the 3 wouldn't be able to use the 2 here. So that's not possible. So this is at least 3. Once we get to 3, I think that there's no problem. So we can be 1 or 3. Now 4 is also not possible as an exsum, because again, 1 is only 1. The 2 would require another 2, and once we get to 3, the minimum is 6. 1, 2, and 3. So we're not doing a 4 on these either. Does that affect the 3 at all? Yeah, so that means this can't be a 3, because if this was a 3, then I can't go down to 2, because there is no 2 exsum. And so, but I also can't go to 4, so we're stuck. So this is not going to be a 3, because this can't be 4 or 2. Now 5 is starting getting in territory that's very easy to do. We could do 2, 3. Actually, 5 has to be 2, 3, but so I think 5 through 8 are all possible. It's just the low digits that are a problem. Now I can't actually put a 1 on these because none of these can be 2. So no 1. Looks like 3, 4, 5 is possible. Now can I actually do a 3, 5 pair here though? But they both require the 2, so no, I can't, right? If I do 3, 5, obviously 1 is only possible as a 1 clue, and then 3 is minimum 6, so these would both be 2s. So I can't actually put a 3 on here either, because it would require the other one to be 5, because we can't put 4. And so now, yeah, so we're 5 through 8, but I don't think we can do more with that. Let's see. Now 7 is actually a problem as well, I think, because the 7, you cannot actually do 7. Sorry, I can do 7 with a 2. I could do 2, 5, but you can't do 7 with a 3, and that's key, because the way you do 7 and 3 is 1, 2, 4, which omits the 3. So 7 would require a 2, but then what do I put the 7 with? I suppose I can put it with an 8. Then this would be a 6. Okay, so that does work. What I'm trying to say is like 5, 6, 7. I think doesn't work. Sorry, with the 6 here. I don't know that I can like do more of this. There's a few more combinations that aren't possible. Like I can't do the 6 here with a 5, 7 like this, because both the 5 and 7 want the 2. Because again, 7 can't use the 3. But that doesn't exclude all of 5, 6, 7. It also doesn't exclude sorry. I can't put the 6 here with a 5, 7, but I can put the 6 here with a 7, 8. So that's kind of like... Anyway, I'm wondering if I have to think about this harder, because there's not much else to think about here. Like these can be pretty large, so I don't really see a restriction on these guys too much. We have this one here. This goes up to 7. Now we can exclude the 2 and the 4, as we did over there. Now this can't be a 1 because this can't be 2. I don't think this can be 2 because 2 would force. Oh no, 2 could go with 1, and then this would be a 1, and that would be okay. So 2, 1 is possible, but not 2, 3. What I was trying to exclude was 2, 3. Because this would also be a 2. It would be 2, 1 like that. So 2, but only with 1. 3 is not possible because both 2 and 4 are not possible here. So then 4, 5, 6. 4 is definitely possible with 5. It's not possible with 3. No, it is possible with 3, obviously. So we go 4, 3. We could also do 4, 5 with the 2, 3 here. 5 could go with 6, yeah, easily. 6 with 7, yeah, okay. So, I mean, how is this restrict? Where are we supposed to be looking? The only thing I can think of is this has more restrictions than I thought. Okay, what if this was a 4? This would be a 5, 6. So let's think about that. If this was 4, this would be 5, 6. So let's just pick a 5 and a 6. I don't think it matters. The 5 would be 2, 3. And the 6 would be 3 and then a 1, 2 pair. That all seems completely reasonable. So 4 should work out. I could even swap the 5 and 6. I don't know what to look at here. I've been at this for a while. Is there something about... That's the only... Okay, 4, 5, 6 is the only way I'm avoiding a 7 over here. Maybe that's the key. If I want to avoid the 7, this can't be 7, so then I can't do 8. So we end up with 5, 6 here, and that forces this to be 4. So maybe having a 7 is an issue in general. So if I have a 7 up here, then I can't have the 5. The 5 is... I could do 5, 6, 7, right? Oh, no. So, okay. Sorry. If one of these is 7, let's pick this one. If one of these is 7, then this has to be 2, 5. That's our only option. Because again, with a 3, you can't actually get to 7. And so that means that... Let's see. We could do 6, 7, 8. And the 8 would be using the 3. And then these two would sum to 5 in some way. And say 1, 4. It would have to be 1, 4 because we can't do 2, 3. So 6, 7, 8 is possible. So 7 at this point does work with the 8. But let's say it didn't use the 8. It wouldn't use the 7 again. We couldn't do the 5 here because the 5 would also require the 2. So this would be either 6 or 8. So let's say it was 6 in this case then. And so then we'd have to do 5, 6, 7, and the 6 would be 3, 2, 1 or something. That works just fine too. So, I mean, there are definitely multiple ways that this resolves. So I don't even know if I can exclude any particular digit. So we can do 4, 5, 6. What if this was 5? It would be 5, 6, 7, which actually works just fine, I think. Okay. And if this was 6, we could do 6, 7, 8. Yeah. So I don't think I can do more with this line. With this line, I think I took care of it. So what's going on then? Maybe it's this one? Okay, so maybe I do need to think about this a bit harder because these are 3 different digits that end up with consecutive x sums. So that does seem a little hard. Let's just think about 2, 3, 4 for a second. Actually, let's think about 1, 2, 3 to start with. First of all, I'm thinking these have to be consecutive as well. Like it's kind of like we have a Renban here that matches this Renban because if I tried to do like, like let's say I tried to do 2, 4, 5. The minimum that 4 is 10, and the maximum that 2 is 8. And so then we kind of need a 3 to bridge that gap, right? So anytime you have 2 apart, you're not going to be able to be 1 apart. Now that's obvious. You have to be at least 3 apart, right? Well, not at least 3 apart. Hold on. The biggest the 2 could be is with a 6. That's 8. And the smallest the 4 could be is with a 10. So at least for 2, 4, we then have to bridge that with a 3. That gets us to 9. And I think that's going to be true no matter what. Like if we do 1, 3, that's a 1. The 3 is at least 6. So that gap is even worse. If we did like 3, 5, the 3 at most is going to be the 11 plus 3, that's 14. And then 5 is, hold on. So 3, 5, I could do 6, 5 here. And that's 14. And then with the 5, I could do 15. So no, so I could do 14, 15. And then I would just need, well, hold on. A 6 is always 21. So if I didn't want to do the 4, I'd have to do the 2, which maxes at 8. So I still can't do the 2 big enough. So I'd still need the 4, even if I did that. Okay. So I think these are Renban. Also, we're not using a 6. Because if we were using a 6, then that would be 21. I would need something to add to 20. And 5 adds to a maximum. Oh, 5 can add to 20. We'd hide the 1 up here. Sorry. But then 4 could not add to 19. Could it? Yeah, because 19 we'd have to hide just 2 outside of the 4 up here. And we can't have those add to 2. So no, we can't use a 6. We also can't use a 1 because the 1 is going to be 1 and then 2 is minimum 3. And in fact, with the 1 here, it's actually minimum 5. So that's even worse. So we're not using 1 and we're not using 6. So right now we're at the 2, 3, 4, 5 range, which means that 3 and 4 are always going to be involved here. I think I've proven they have to be consecutive. I hope I have. So we got 3s, 4s there and 3, 4s there, which means this is not a 4. So I think 3, 4, 5 is possible. Is 2, 3, 4 actually possible? Let's actually take a look. Let's fill out 2, 3, 4 here. Oops. Oh my gosh, why can't I? Let's fill out 2, 3, 4 here. So 3 is minimum 6. 4 is minimum 10. Let's start with that. 4 being minimum 10. I'd have to put a 1 here, actually, in order to get to 10. Because this can't be 2, 3. That's going to be true wherever the 4 is, if we do 2, 3, 4. So I could do 10 here, and then this would have to be 9, which is 3, 6. That's its maximum. And then this would have to be 8, which is 2, 6. That doesn't work. So 2, 3, 4 is not going to work. Because let's think about the 3. If this was a 5, that's 8. We can't do a 9 because we can't do 2, 7. We can't do 9 with 4 cells. Geez, this takes a lot of thinking. Maybe there's some easier way to think about this, but so therefore, so 8's too small, so it would have to be 9, and then this would have to then be the 8 because we can't do 8 and 4, but 2, 6 would be the 8, so that doesn't work. So we're not doing 2, 3, 4. So I think we're doing 3, 4, 5, and let's just pick some order, and then we'll pencil it. So we have to do 3, 6 in order to get, and again, the 6 is just above the 3. We have to do 3, 6 to get to 9 so that the 4 can then be 10. And this could be the 1 or the 2, and then we just fill out 1, 2, 3 like that. And then the 5 has to make us 11. That doesn't work. 9, 10, 11. Wait, how are we doing this? Is this possible? I proved 4, 5, 6 doesn't work. So we do 3, 6 to get to 9, and then the 4 is 10. That's its minimum. But then the minimum for 5 is 15. Oh, no, sorry, this is a 3. Duh. Oh my gosh, that's the issue. I think... So let's start with the 5. The 5 minimum is 15. What's the 4 maximum? Let's see. So this is 15 through 20. This is 15 to 20. This is 10 to 18. And 3 cells is 6 to 14. Okay, well, the very first thing I can do is put 3, 4, 5 here, 3, 4, 5 here. So this is not a 5, and these are 1, 2, 6, and these are 1, 2, 6. Okay. So does the 1, 2, 6 limit us at all? One of these has to use the 6. So let me think about this for a second. We've got, so the 3, let's just go in order. So let's do the 2 ranges. The 3 is from 6 through, and 3, 5, 6 is going to be 14. So 6 to 14. The 4 is 10 to and then 4. So the outies for 4 could be 1, 2, which is 3, and 21 minus 3 is 18. So 10 to 18. Let's actually just do this here. 6 to 14, 10 to 18. And then the 5 is 15 through 20. Okay. And then these are going to be consecutive. So this actually it has to be at least 9 because we'd have to go 9, 10. But 10 is not actually possible because this is minimum 14. So if this is minimum 14, this is 13 or 14. And then this is maximum 19, not 20, because this is max 18. But actually, this is max 14, so this can be as big as 15. And so then that means that this is as big as 16. So actually, we always have a 14 and a 15 on here, and it's with a 13 or a 16. Now, this is 2 or 6 now. So this can't be 6. This is an X sum as well. So maybe that's... So this is obviously not a 1 X sum anymore. It's also not a 3. In fact, this is at least 3. So this has to be a... We can't use 7 with 3. We can't use 5 with 3. Hold on. This has to be the 3, but there wasn't a... I think I broke it. Can't be 3, 4, 5. Oh, there's some interaction here with this X sum and this consecutiveness. Remember, we said 7 can't be 3. And 3 is at least... In fact, if this was 3, it would be 3, 4, 5. That's the minimum, which is 12. But if that was 12, this would... Okay, so clearly I made a mistake here. Darn it. I'm going to have to use 2 down here. Let me check if 1, 2, 3 still is possible. This X sum is... Well, let's think about this X sum just on its own. So I'm going to have 3 consecutive digits that then become this X sum that maxes at 7. So if this was 1, 2, 3, if this was the 1, let's not even worry about how to fulfill this X sum yet. If this was the 1, this would be a 1, and this would have to be 2, and then we couldn't be 1, 2, 3. So no, that's not a 1. Now if it was 1, 2, 3, we could put the, if we put the 3 here, this would add to 6. This would be 6, 5. That works. Okay. So can I do how about a 2 here? If I was doing a 2 here, this would be a 1, 3 pair. So I'd either be a 3 or I'd be a 5. Which would make this a 4 or 6. Okay. So, but the thing is, I don't think 1, 2, 3 is possible. So if I have a 1 somewhere, and I want this to be, say, 2, 3, these have to be consecutive. The X sums have to be consecutive. But I can't do an X sum of 2. It's just not possible. The 2 is at least, in this case, at least 6. So 1, 6, and then whatever this is, 8 or something. That's not consecutive for this Renban. So I'm not going to include a 1. Now, if this was at least 3, I can't do 7. So my only choice would be to do 6, which includes the 1. So this has to be a 2. And 4 is way too big, because 4 is at least 10. This would have to be 9. So this is a 2, for sure. This is a 2. Which means I missed a case where 2 actually works. Now we know this doesn't include the 1. So I think this has to be 3, 4, which does make this a 9. But that can't be 9. That would be 8. So how am I... oh, sorry, with 2... No, sorry, I could do 2... I could do 2... We aren't using the 1. So I could do 2, 3, which would make this a 5. I'm not using all 3 of them. Or I could do 2, 4, which makes this a 6. Or I could do 2, 5, which makes this a 7. So this is 4, 5, 6. Now, this is maximum 8. This maximizes at 8, which means that I think I have to do 8, 9, 10. Yeah, I'm gonna do a 3, 4 pair here. The 4 is going to add to 10. The 3 is going to add to 9. Okay. And so then this has to be 2, 6, which makes this a 6 or a 7. Oh, but the best I can do is 2, 4. Wait. Oh no, this could be 5. 2, 3 is 5. Sorry. That's a 4. Okay, so I have the order now. This adds to 10. So this is a 1, 2, 3 triple. And so this can only be 1. That fills the 5 here. Okay, we're making progress. And so now this adds to 8. So this has to be a 1 to get us to 9. So this is a 9, this is an 8, and this is a 10. Finally, okay, that's how we had to think about it. Is the interaction here. Okay, I can do some penciling here. This is 2, 3, 4. This is 1, 5, 6. Now this can't be a 6 because it would make both of these x sums a 21, which isn't going to be possible on a Renban. And it can't be 1 because it would make both of them a 1. So actually, this has to be 5. Okay. If this is a 5 and this is somehow consecutive with it, I really think this can't be a 1. It would be a 1 with at least 15 on a 3-cell Renban. So that's 6 and that's 1. That does make this a 21. All right, so then the 5 has to be the 20, which then puts the 1 up here. And the 1 up here will make this 5 out of 20 no matter what we do the order of the other things. And so then this can't be 22. This has to be 19. And I hope it is. Yes, it is. The 2 is over here. Okay. Perfect. All right. Took me a long time to get here. I was not thinking about this right. All right, so this is going to be a pair. This is 5, 6. This is a triple. This can't be the 2. So 2's up here. And then we need a 4, 6. But the 5, 6 pair says that's not 6. So the 6 goes here. And so then this pair is 1, 3. We know the order, 3 and 1. And then this, we get a 3 in the corner, right? And this is a 4, 5 pair. All right. So probably have to think about this now. Is there any more? Let's see. There's a little bit more of a Sudoku we can do. We can place this 1, which actually might help this x sum quite a bit. Did we finish the 1s? Yeah, we finished the 1s. 6 is in one of these 2, so it will be in this x sum. Oh, no, but no, there is no x sum here. Sorry, so it won't be. There isn't one. Let's see. I probably should pencil these. So 2, 3, 4, 5. Or 2, 3, 4, 6. That's not a 6. Well, this isn't going to be 6. That's not a 21 x sum. 4 is at least 10. So neither of these are 4 either. So that's a 2, 3 pair. So that's our 4. That makes this a 6. So that's in range of everything. So if this was a 2, it would add to 3. So it can't. That's 3, that's 2, because this is at least 5. That's 2 and 3. That's 4 and 2. All right. Hopefully the way I thought about this was correct, because I kept that penciling. This is a 4 or 5. So this is a 3. We already add to 4. So we're either going to be an 8 or a 9. We can't be the 9. So this is 8. This is 7. This is a 4 in order to get to 8. Now this is 7, which is 2, 5, which actually was something I speculated about. This is the 5 looks down. So that's 5. That's 2. That's 3 and 2. I think we're finishing. That's a 3. And then we need a 4 and a 6. Nice. And it's the correct solution. All right. That took me a while to find the break-in. The break-in was right here. Probably could have been done on its own. Just thinking, like, without too much case checking, just thinking about how maybe thinking about how these had to be consecutive because these were consecutive. And then thinking about this x sum here, meaning max 7. I think those were the kind of the important deductions there. Cool. And then not being able to put a 1 down here was also important. Yeah. So really interesting interaction here. And then it flowed from there very nicely. We flowed to this and we flowed to this. It just took a bit for me to realize that I was trying to flow the other way, I think. Anyway, cool. So yeah, long solve, but maybe sometimes watching me struggle through a solve can be helpful for how to approach a puzzle that you're not sure how to solve. All right. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.